here. Here linear displacement, there we are having the angular displacement. Here we are having linear velocity, there we are having angular velocity. Here we are having your tangential or your centripetal acceleration, and there we are having your angular acceleration part here. Now, main part what we have told that in case of translatory motion, listen carefully. In case of translatory motion, all the particular particles of the system or the object here, they will have the same velocity. They will have the same velocity here. But in the last class only we have discussed that when we are talking about the rotational motion and all, I told you the concept of linear velocity as well as the angular part. So in this case, let me ask from Praveen Singh. So what we have discussed in the last class here, that out of this linear velocity and the angular velocity, which will be remaining same or which will change?
Ma'am, the linear velocity will change.
Yes, linear velocity will change here, and linear velocity is equal to r omega. And here the angular velocity for each and every particle at different position and all, that will remain same only. So here, depending upon the radius, the distance from the fixed point and all here, your linear velocity will change. And here only I told you the example that if you are having a stone here and the stone tied to a thread and or a string and just you are rotating it, you'll feel that it's simply rotating it, not dangerous and all, because the velocity is less. But as soon as the particular thread of the string, that it will increase, it will be longer and all, that time you will feel that the velocity will increase, and if that time you will release the stone, it may hurt someone here nearby. So here, depending upon the distance, your radius here, the distance, the linear velocity will change, but the angular velocity part will remain same. Now, here only in the last classes, I told you about the direction of the angular displacement or the angular velocity. Just any one of you tell me that what you can say about the direction of angular velocity. I told you that it is given by with the help of your some rule. So just any one of you tell me if you are having any object here, moving here and the circular path and all from here to here, suppose in this direction and all. That is only I told you that what you can say about the direction of this angular velocity. Just
Ma'am,
any
it will be perpendicular in the plane of rotation.
yes, it will be perpendicular, because this is one thing. These parts are very, very important here, because in NCERT only, in the bold letters they have written. So here we are talking about the particular direction of your angular velocity or the angular displacement part. So I told you that here we have to apply your right hand thumb rule. You're getting the point or not? Right hand thumb rule, I told you that you have to turn your fingers in the particular direction where the particular object is moving in the direction, whether clockwise or anti-clockwise. And then the thumb will represent the direction of your angular velocity part or the displacement part. So here, in any case, a simple part you can say that it will be always perpendicular to the plane of the motion taking place is there. Or better you can use that, it can be given with the help of right hand thumb rule. So here just we have to curl the finger in the direction of the motion part, then the thumb will represent the direction of the angular displacement or the velocity part here. So this part already we have discussed. Now today I told you that last class we have discussed about the center of mass. So let me ask from Saloni Dhakar. So what we have discussed about, so that center of mass here? And try to
Yes,
explain here. Tell me Saloni.
Cent center of mass is a point where the entire mass of the system of particle is concentrated.
Yes, it is supposed that it considered to be a point here where we are assuming that the entire mass of the particular system of particle or the object is concentrated. So here and today I was discussing about that how to find out the position vector of your center of mass having two particles, or it will be extended to your n particle system here. That part is very, very important. So before that, listen one thing, because in exam It may happen that sometimes they'll be asking the derivation part, or mainly they'll be asking you the question based on finding the center of mass of different system and all. That is very, very important. And three examples are given in NCERT book just after the class and all. I'm telling you. Tomorrow we'll be discussing this three numerical part. Today you go through the particular numerical. The examples part are very, very important here. Now, so here, let us find out the position vector of center of mass of two particle system. The simple one we are taking, and then we will be generalizing it for n particle system here of two particle system. Now, as I told you that derivation part is important to just know the concept and all. Before that, just solving the numerical part, you can first just see the expression part. The expression part should be, because there are so many formulas there which you have to keep in your mind. Otherwise, like suppose when you're going for the derivation also, if the formula will be known to you in mind and all, so in any part, in any state, if you're doing any mistake, that time you can it. Suppose the formula is only not known to you here, then simply suppose in any part if you are doing any mistake, then the entire process will be wrong and all. So try to just memorize each and every formula. Better have the habit here that like chapter wise. Suppose today first chapter you have read, so whatever formula you are having that part in the early morning or somewhere at time when you are going for the sleep and all, that time you just recollect it, and next day suppose you are going through some new formulas and all, then just have the particular, you just combine the first and the second part here, starting from the first again come to the whatever you have read today. In this way it will enhance the memory power also here, like what not like that today whatever I have read that part only I will revise. In concept part, theoretical part, or the formula and all, try to recollect it from the beginning till whatever you have read. Now, so here in this case, suppose we are having a system of particles having two particles. Here I am having one particle P1, here I am having another particle P2. This P1 is having mass M1, here it is having the mass M2. These are at the position that R1, and here it is at R2 from the origin, and this is the coordinate axis x-axis, and here is the y-axis there. And here I am having a system of particles, so I am joining them now. So just now, whenever you are going to the derivation part, you have to write down the statement. Whatever unknown quantity you have chosen, you have to mention it. So here, what you take here? Consider a system of particles, a system of two particles. System of two particles P1 and P2 having masses M1 and M2 respectively. Now, this particular particle P1 and P2, they are at the position vector R1 and R2 from the origin. So you have to mention that part also. P1 and P2 are having position vector R1 and R2 respectively from the origin. So quickly write down this part here, because in the derivation we have to write down so many things. So it won't be possible in the write down the blackboard or not. Just write down the language part first, that here we have considered a system of particles having two particles P1 and P2 having masses M1 and M2, which are at a position vector R1 and R2 from the origin in the coordinate of Cartesian axis here. So please write down this part, then we'll be going for quickly. So the language part written here?
Yes, ma'am.
Now.
No, ma'am.
Okay, let's write down this. Listen here, we don't know about the mass of P1 and P2. Just arbitrary we are taking M1 and M2, maybe they are equal, not equal, nothing is known to you, just M1, M2. Not necessarily that they will be equal and all. So here, we are considering that somewhere we are having the center of mass. Here, somewhere, not in the middle and all, somewhere we are having, because only the case when the masses will be same. Under that condition only, the center of mass will be at the center. So we don't know about the masses M1 and M2, whether they're equal or not. We are taking that the masses are not equal. If the masses are not equal, we can't say that the center of mass will be lying exactly at the center. So somewhere, suppose here the center of mass is lying, which we are denoting by C. And here, let R. And here let RCM denotes the position vector of the center of mass from the origin. So here you represent that let C be the center of mass. Let C be the center of mass of the system of particles. Of the system of particles. A particle is having only two particles here. Okay, and here in this case, and RCL be the position vector. Be the position vector of center of mass from the origin. So be attentive, dear. Just one by one, we go through the particular statement. All if really you are attentive in the class, then hardly, dear, one time if you are going through the derivation part, easily you will be deriving it. No need to spend much time at home, dear. That's why I'm telling you. Whatever we are starting from that, one by one, just you have to put in your mind, dear. Simply we have written this equality to mass and all R1, R2, and the center of mass we have marked denoted here, and the position vector of the center of mass part. So please quickly write down this particular statement part and just mention in the comment whether written or not. Then only we going for the derivation part further.
Written, ma'am.
Okay, dear. Now, for the particle P1 and P2, for the particle P1 and P2, let us go for finding the velocity vector and the acceleration vector. So here, for P1 here, the velocity vector we are denoting as V1. This one is V. Don't get confused with R and V. This one is V1. This is called V1 will be what? In terms of position vector, you know that the particular chapter you have already read here, this velocity is what? Instantaneous velocity, if you are talking about, it will be the rate of change of velocity.
Displacement.
Distance upon time.
Is your dr by dt here. So here it will be equal to your dr1 by dt. So here for P1, for write down the language that the velocity vector, because you're going to the derivation, so write down the language also. The velocity vector V1 is denoted as dr1 by dt. Now here similarly the acceleration vector. The acceleration vector is denoted as a1 is equal to what? dv
by dt.
1 by dt here, and already this v1 is equal to dr by dt. So here this acceleration is first order derivative of velocity, or further it will be your second order derivative of what? First order derivative of velocity here, and second order derivative of this difference.
Acceleration.
What dear?
Acceleration.
The acceleration only talking about. I have written that acceleration is equal to dv1 by dt. Suppose this one only further, we are replacing v1. We are replacing v1, right? We are having d by dt here. This v1 is equal to dr1 by dt. dr1 by dt. This is v. This one is r. So here, this one we can write down as your A1 is equal to d square R1 by dt square, the second order derivative. This part you have read or not?
Yes, ma'am.
Like earlier we are having in this equation of motion already here, like we are having v equal to dx by dt. The expression will be equal to d square x by dt square. So here we are having the position vector r. So here acceleration a1 for this particular particle p1 is equal to your d square r1 by dt square here. Now similarly you will be writing for your particle 2. Now for particle 2. For P2, again I'm not writing velocity vector, simply I'm using the symbol now because already we have mentioned the P1 and all. So here, for P2, your V2 will be d R2 by dt. Till now, any problem you are having, so you can ask me. Nothing we have done here, just language part we have written and whatever already in equation of motion part and all, you have read about the integration and differentiation part regarding velocity and acceleration. That part only we are using. So here V2 is equal to dR2 by dt. And here further the acceleration will be. Now just tell me any one of you. Now this Garima, there we are having your acceleration A1 is d square R1 by dt square. So for particle 2, what will be your acceleration vector? Garima, just tell me dear. Shreya Prasad.
Ma'am, d square R2 upon dt square.
Just the position vector will change. D square R2 upon dt square. So till now just we discussed about the velocity vector and the acceleration vector of particle P1 and P2. Now what happened? Listen carefully. Here suppose at P1 an external force F1 is acting here. Here P2 at P2 here an external force F2 external is acting. Now you know that already in the beginning of the class only I told you about the internal forces and the external forces here. In case here the external force F1 acting at P1, here I have marked external force F2 acting on P2. But here the P1 and P2 they will also have the mutual interaction, and because of this mutual interaction the force is known as what kind of force here? Already I told you. The force responsible for the mutual interaction. In the first class only I told you about the forces there. Just any one of you tell me.
Internal force.
Internal forces there. So here force on P1 due to P2. It will be your F12. F12 means force on 1 due to 2. In this direction. Similarly, force on 2 due to 1, F21 in this direction. Here, because of this internal forces, this F12 and F21 are the internal forces acting between the two particular particles here because the mutual interaction and all. So here you have to mention now whatever unknown quantity we have marked like F external and all. So here write down. This derivation part is very simple only, hardly this particular symbol, whatever you are using, that language part is a little bit lengthy and all, otherwise this derivation is very simple here. So here you have to mention that let F1 external and F2 external act on the particles P1 and P2 respectively. Or directly you can use that let external forces F1 and F2, whatever language you can use. Instead of writing external again and again, you can use the statement that let external force F1 and F2 is acting on the particular particle P1 and P2 respectively. F12 and F21 are the internal forces because of the mutual interaction of particles P1 and P2. The particles are interacting and all because of the internal forces, your F12 and F21. Of course, suppose you are getting confused, so you can mention here that it is here defined as force on one, P1 due to P2. If one is known to you, so other you can just get the idea. And here, this one represent your F12 as force on P1 due to P2 dear. Now, till now, just we have written the part dear. इसमें कुछ डाउट होने का ऐसा सवाल होता है नहीं आपका. Simple, just whatever terms we have used, that part only we are defining now. Now, just write down this part quickly. Just write down the part quickly dear, then we are going for further. So here F1 external, F2 external, here F12, here F21. Now we will be going for here the total force at P1 and P2. So just after writing this part, write down in the comment.
Done, ma'am.
Anyone left here? Written. Anyone left? Yes or no, something should reply dear, because all are not having the same skill of writing and all. If someone is left, so I'll be waiting, otherwise simply I'll be going further.
I'm noted.
Okay dear. Now here, the total force at P1. Total force at P1. Just tell me, at P1, you are having the external force F1 external, and you are having one more force, your internal force F12, force on P1 due to P2. So here, the total force at P1, suppose we are writing F1 only. Here we are writing F1. The total force F1 will be what? So let me ask from here. Only two forces are there, so I am asking about the total force. So Vijay, just tell me, at P1 here you are having only two forces here, F1 external and here your internal force F12. So the total force at P1 will be what? It will be the sum of Vijay. At least something people interact. ना मतलब क्या मतलब पढ़ाने का बताओ? Nothing people are interacting dear. Simply I'm asking that suppose that you are having 2 bananas and 3 bananas and all. So what will be the total bananas we are having? 2 plus 3. So here I am having at P1 the force F1 external and the internal force F12. So what will be the total force? If I am denoting the total force by F1, then what will be this total force? Pankaj Kumar. Pankaj Kumar. Pratibha Sudhar. Whether if people are sleeping dear or what, if the answer is not known to you, you can say simply no. Or just joining the meeting, आप कंबल में एकदम सो रहे हो क्या? कोई मतलब ही नहीं है सर. For you people, it's better to have a simply passive interaction here. Means the teacher will be coming to the class, simply अपना बकबक करे अपना और चले जाए without asking anything from you people. This will be the best method for you people. Simply हमारा कोर्स भी आगे बढ़ेगा dear. Because we are asking from you now, that's why we are lagging behind. In other classes, they are just finishing the course. हम पूछते हैं सबसे बेटर तो आपको आंसर तो आता नहीं कुछ भी. तेजस्वी श्रीमाली, just tell me बेटा. तेजस्वी श्रीमाली.
Yes, ma'am.
The total force at P1 here, what will be the total force? F1 we are talking about.
F12.
What dear?
F1 plus F12.
F1 external plus,
Yes, ma'am. Plus F12.
yes, F1, the sum of the external forces and the internal forces there. Similarly, at P1, total force at P2. Here, we are writing F2 is equal to that is sum we're talking about simply there. So it will be your F2 external plus F21, the sum of the internal forces and the external forces there. Separately, we have done for your P1 and P2. Now, but we are talking about a system which is consist of two particles. So let us go for your total force existing on the system. So you are knowing the idea about force at the particle P1, force for particle P2 also is known to you. The system is made up of your two particles P1 and P2. So here, if will be going for finding the total force of the system of these two particles. So what is it going for? Simply it will be adding the equation 1 and 2. Thus we'll be getting the idea about the total force acting on this system of two particles. Yes or no?
Yes, ma'am.
We simply when two particles are there and both the particles, whatever force exerted is known to you. So just you have to go for adding them. So here we'll be writing that total force on the system. System is here consists of two particles. You'll be getting that by adding equation 1 and 2. Just you have to add equation 1 and 2 and you're getting the total force. So here I am having F1 plus F2. Just simple like in maths also how you are adding the equation part and all, left side to left side, right hand side to right hand side. So here I am having F1 external plus F12 plus F2 external plus F21. Just write down quickly to this part. Just we are adding the forces at P1 and P2. Be fast here. At least today we have to complete this part, the derivation part, and some significance are there. Just
Written, ma'am.
written good. Anyone left? Anyone left?
Written, ma'am.
So here, this F1 and F2, suppose we are taking the total force as F only. So here, the total force we are denoting as capital F here. This F is equal to F1 external plus F2 external. Just we are arranging them. Plus, we are having here F12 plus F21. Now, listen carefully. If we will apply Newton's third law of motion, Newton's third law of motion is known to you that here for every action there is an equal and opposite reaction. You know that here these internal forces which are mainly because of this mutual interaction and all, they are exerted in equal and opposite here. The internal forces here exerted by this particle will be equal and opposite. Then what we can say? So here if we apply by Newton's third law. By Newton's third law of motion. By Newton's third law of motion here the internal forces are equal and opposite. So can we write down that F12 is equal to minus of F21? Prahas Mande, yes or no?
Yes, ma'am.
So here, just write down that here, that internal forces are equal and opposite. Equal and opposite. Therefore, F12. A class of F12 is equal to minus of F21. So here we can write down that the sum of these two forces will be equal to 0. Means here F12 plus F21. The sum will be 0. So in the particular expression, here this particular term will contribute to what? F12 plus F21. Just Garima tell me. Garima. Just now I told you because we will third term motion F1 0 here. So here we'll be writing the force F will be equal to F1 external plus F2 external. Now, so here this part is very important here. Here this part we written that by Newton's third law of motion here, that internal forces are equal and opposite, so they cancel out. So whenever we are talking about center of mass, and we're going for your motion of center of mass and all, that time we have to keep in mind that we have to consider the external forces only. We won't be considering the internal forces, as the internal forces being acting equal and opposite, they will cancel out. So whenever you are going for motion of center of mass and all, you have to consider only about the external forces. So here F is equal to F1 external plus F2 external. Now F is the total force of the particular on the system here, having the particular masses M1 and M2. So here we are talking about the two particles are having the mass M1 and M2 here. So here, if we want to find out the total mass of the system, simple, 2 rupees and 3 rupees, total you are having 5 rupees. So here, let capital M be the mass of the system. Here system is again system of two particles only. So this capital M will be equal to what? M1 plus M2 or not? Because we are having two particles and their masses is M1 and M2. So M1 plus M2. This M is equal to M1 plus M2. Now, because of this force here, there will be an acceleration in the system, and that acceleration we are denoting as HCM, means acceleration of the center of mass we are taking. Because of this force, now because of the force F, there will be acceleration Cm of the particular system. So by applying Newton's second law of motion, so let me ask from here, Dipal, tell me the statement of Newton's second law of motion. I'm asking the statement part, I'm not asking from anything from here. Just tell me the statement of Newton's second law of motion.
Force is directly proportional to rate of change of momentum.
Yes, your force is directly proportional to the rate of change of momentum, and direction part also you have to tell here. So here, in this case, I can write down that because in the second law of motion only, when we are writing that F external proportional to dp by dt, from that, if the force constant K, proportionality constant known as the force constant, we are taking 1 here, we can write down that F equal to ma. So here, for this particular system, we will be now using Newton's second law of motion here for writing these particular forces in terms of mass and acceleration. So here, by using, now next part will be by using Newton's second law of motion. Everything is very simple here, just go through it nicely. And just at home, just one time you go for the revision and just have the practice by writing. So here in this case, by using Newton's second law of motion, Here I can write down that total this particular F can be written as capital M into acceleration of the center of mass CM we are denoting, and this F1 external will be for particle P1 M1 A1 plus M2 A2. But our purpose is that what? Thus we want the expression in terms of your expression and all. In the heading only written that we want to find out the position vector of the center of mass. Means whatever we are having this equation, we will change it to the particular form of position vector here. So here, now this particular acceleration CM, center of mass, if you're talking about, the center of mass is having the position vector RCM. So can we write down? Suppose this M is shifting that side, here mass is multiplied. That side, if you will be shifting it, it will be your M1 A1 plus M2 A2. The will be putting vector sign on M1 also. Jyoti Meena. Should we put vector sign on M1 and M2? Jyoti Meena, should we put this particular vector sign on M1 and M2? Simple question also if people are not responding anything.
No, ma'am.
No dear, because they are the vector part only. They are the scalar part dear, so why are you putting the vector sign and all? So here, over divided by capital N. And capital N is what? The sum of the masses of the two particles. Means capital N can be replaced by M1 plus M2. So here, if this one I will replace it by the position vector. So second order derivative of the position vector. So we can write down that d square RCM center of mass, position vector for the center of mass by dt square is equal to M1. This A1 we can replace because of the beginning only I told you A1 in terms of the position vector part. So just tell me Saloni Thakur. A1 dear. Saloni, A1 in terms of position vector for the particle 1. You all are requested to turn your camera on, dear.
Ma'am, can I?
No, Tejasvi, I know hardly few are there who are really attending in the class, dear. Others I don't think. Whether they are attending the classes or not, God knows. From next time, you have to just, throughout the meeting, you have to turn your camera on.
Okay, ma'am.
Otherwise, simply we won't be giving you the Muppet attendance also, dear. Simply will mark your absent. So this M1 now here, this one can be written as Praveen. A1 is what? Because
Yes,
of the teachers are supposed to ask from only few students. The teachers never do impossibility here because you people are not giving any response. Whether right or wrong, that part is different. At least you should give some reply. Praveen,
yes,
A1 can be written as.
ma'am. A1 can be written as ma'am second derivative of R2 vector.
Yes,
Sorry.
d2 square plus M2 here similarly d2R2 by dt square whole divided by n. N can be written as M1 plus M2 here. So please kindly write down up to this part, and from here hardly 2 steps are there for the main derivation part. So please quickly write down up to this.
Done, ma'am.
Written.
Yes, ma'am.
Okay, Saloni, okay, dear. You are not audible to me. And some people are doing part in the beginning, they are attending the classes here, and just before, suppose I give the attendance part, that time they are joining the meeting. Just for the attendance purpose, if you are coming to the class, then no use. Simply you tell me your name here, or you put in your attendance part. सिर्फ attendance ही चाहिए आपको, तो कोई मतलब ही नहीं class होगा. Now here I will write d square r cm the position vector of the center of mass by dt square. We know that m1 and m2 they are the constant here. Constant case means here the simple rule of derivative. Suppose I am having d by dt of 2x. d by dt of 2x. Can we write down this one as 2 into dx by dt? Constant will be coming outside or not?
Yes, ma'am.
So here, so if from this we can write down this. So why not we can write down from this to this? We can write down or not? The constant part we will put inside here because it has no rule. Because if we apply the rule for the multiplication in case of differentiation like d by dt of u into v. So when we go for the derivative of the constant term, it will give you 0. The term is 0 means here. Suppose you are going for the formula d by dt of uv. So u dt by dt plus v du by dt. If one term is constant, then this du by dt term will be your 0 dear. So that part is not important. So here this m1 will put inside, this m2 also will put inside the derivative and all. So here we will write down that d square m1 r1 by dt square plus d square m2 r2 by dt square whole divided by m1 plus m2. Now further will be arranging it. Here we write d square position vector of center of mass by dt square. Take out here d square by dt square common, and here will be your m1 r1 plus m2 r2, and here m1 and m plus m2 is also constant. We can put inside the bracket, combine together. Here we are having d square by dt square of position vector of center of mass is equal to d square by dt square of here m1 r1 plus m2 r2 by m1 plus m2. So from here we can just equate the term like here also dt square by dt square, d square by dt square, here also d square by dt square. We don't cancel them because here you have to go for taking the integration and all. So this obviously they will be getting cancel out and all. So here RCM will be equal to m1 r1 plus m2 r2 by m1 plus m2. So this is the particular formula to find out the position vector of the center of mass. And if throughout you have listened carefully, then hardly after seeing one time you will be getting the idea how to find out this one. So this formula part is very very important here. And now we don't have enough time. Now in the next class we will be discussing the physical significance of this particular term. Just now we have derived. We don't have any much idea about physical significance part. So here you have to write down that here the position vector for the center of mass is equal to m1 r1 plus m2 r2 by m1 plus m2. We will further discuss in the next class. So meanwhile, once again, just attend to your roll call. Roll number 1.
Present, ma'am.
Roll number 2. Roll number 3.
Present, ma'am.
4.
Present, ma'am.
5. 6.
Present, ma'am.
7.
Present, ma'am.
9. 10. 11.
Present, ma'am.
11. Devendra. Roll number 11. Devendra.
Roll number 10, present.
10 done beta. 12. Divyanshu was present.
Present, ma'am. 12.
Yes. Now 13.
Present, ma'am.
14. 15. 16. 17. Pankaj was present only. Prahas 18.
Present, ma'am.
19.
Present, ma'am.
20. 21.
Present, ma'am.
22, 23, 24, 25, 26, 27, 28,
Present, ma'am.
29, 30, 31, 32, 33, 34, 35,
Present, ma'am.
36. These are
Thank you.
the- Thank you all. So now you can leave the meeting.
Thank you, ma'am.
Thank you.